Hello and welcome to this video about INAV 8. Now, for those of you that have been watching my channel for a long time, you'll know that I am an INAV fan. I've been using it since about INAV 1.2, back in those very early days where a guy called Konstantin Charlamov forked, and that's not a rude thing, a version of CleanFlight to fix all the navigation stuff, called it INAV Flight, and then very quickly it became clear that INAV Flight was becoming so different from CleanFlight that the two lots of code could be merged back in, and INAV became its own thing. And here we are. INAV 8 is upon us, and I had an opportunity to chat to one of the developers. This is a gentleman called Marc. Marc is an incredibly kind, generous guy with his time, and he agreed to have a chat with me to talk about some of the cool new features that are coming in INAV 8, and lots of them are going to be interesting for those of us who have more sophisticated flying requirements and who like the fixed wing stuff too. Now, I'm going to put time codes down below, so if you want to zoom to a specific question and hear the answer again, you can. Warning, there was a bit of an issue with Marc's microphone. We did try and record it locally at Marc's end in case it was a weird thing with Skype. Turns out it wasn't. There is a little bit of clicking and popping as his audio is clipped. I've done my best to try and fix it, but unfortunately it isn't ideal, and I don't want to ask Marc to spend another 45 minutes of his life recording another video. I don't think that's very fair on him, and I also didn't want to kind of just go over everything that he said myself and represent it as my knowledge and know-how, because it isn't. He knows far more about this stuff than I do. So links down below to Marc's channel and other bits and pieces, but let me hand over to Marc and let's talk about INAV and some of the new stuff that's coming. So thank you again to Marc for joining me on this call. Thank you for listening to that introduction. Again, Marc is one of the INAV development team and a bloody nice chap. Marc is also the person that's helping me currently do my INAV auto landing video that I'm currently working on. And I've had to wait till this part of the year because I needed the grass in the field that I fly in to die back enough so that the LiDAR works. But that's a whole nother story. So as I said in the introduction, this time is about the INAV 8 new features, and there's lots and lots of new ones. Go and check the release notes. The release notes, I'll put a link down below in the video description. Go and have a look at those, because if you see how much work has gone into INAV 8, it has been spectacular. There's probably been about 20 things going on just for the MSP support, and we'll talk about that in a minute. Before we get into the detail with Marc, and thank you Marc again for your time, I really appreciate this, buddy. Marc's pulled out 5 or 6 things that in his opinion are the headlines of why you would update to INAV 8 over a previous version, but I give you a flavour of some of the other stuff that's in there. There's a new setup wizard, particularly around fixed wing. That's going to be incredibly useful. So it actually will step you through some of the settings and configurations, which I think is a really good idea. I see lots of issues with that, helping people with INAV in fixed wing here. There's an easy upgrade path from 7 to 8, as there usually is from the previous version. It's kind of just a diff all cut and paste, although don't always just assume it's always gone tickety-boo. I would recommend always triple check that all of the tabs still look like you want them to. There's now ADSB support. Now we're going to talk a little bit more about what ADSB is in a minute with Marc. Loads of improvements to the on-screen display layout, cutting and pasting, because if you remember there's 4 tabs that you can flick between. Most of us don't use that, but it does mean that you can have one with all your elements in, and you can flick to one that has very few of the elements in and go between the two. You can now cut and paste, and there's also better support for custom OSD stuff too as well, which is great because I love all the custom OSD stuff. Check out my videos with Sneaky FPV, who does some fantastic work on the font stuff. If you have an assist now token, then you can get a uBlocks assist to give you faster GPS locks, which is always nice, particularly when using a HD system and you're desperately trying not to get it overheating before you get the thing in the air. So one of the things I'd like to talk about before we get into the main list is actually about the changes to MSP. Now, MSP, multi-wee serial protocol, that's how long we've had it, since multi-wee days, back when we all loved 8-bit, and it actually used to work quite well. But it still exists as a protocol that's at the heart of lots of the flight controller systems that we fly today. But looking at all the stuff that you guys have done for INAV 8, there was dozens and dozens of changes and updates to the MSP protocol. What was that all about, and why was it needed?
So yeah, one of the main changes in MSP is actually not that big. It's basically using a specific flag in the MSP message that was not used before for the MLRS RC link that you already made a video about a while ago. And this was introduced because MLRS has to request information from the flight controller constantly in a loop to get data for telemetry, because unlike Mavlink, where you get a constant telemetry stream just from the flight controller without any requesting, on MSP it's a pure ask and response protocol. So MLRS has to request all these data in a constant loop. The problem with that, or a result of that behavior, was that all the response messages also got sent to the ground. Of course, they have to get them passed. But then MLRS could not distinguish between the messages it requested itself, or it got an answer for, and messages that a ground control station has requested from the flight controller. So the result was that the ground control station was basically flooded with all the messages that MLRS requests, and sometimes, especially with the MultiWii Planner ground control station currently for Linux and Unix systems, and also with the INAV Configurator 8, we had the problem that they struggled to connect or stable transfer data because they got a lot of crap they didn't expect to get, and that had to be filtered. So we gave the possibility for an RC link who needs to request these messages to flag them with a bit, and then the RC link can just filter them out and not send them out to the serial link. So the RC link can now independently communicate with the flight controller parallel to the ground control station software. Another change that also was implemented as well for MLRS is the MSP link stats messages. There are actually two messages, MSP link stats and MSP link info. The RC link stats message sends basically all the general information that we always get from other RC links as well, like the link quality, the RSSI, the signature noise ratio, stuff like that has to be submitted in real time and you want to have in your OSD and in your black box log. And then there is the RC link info message that contains information and gets sent very slowly only about your current band you're in, about the operation mode, and a few other things as well. And the target is in the future that other RC link systems like ELRS, if they ever implement MSP RC as well, to allow them to use these same messages and provide all the information over MSP that was not possible before and needed a separate link for like the CRSF protocol or SmartPort, for example.
So if you are a pilot that uses, at the moment, something like MLRS, and Marc and I have made a video on that already, I'll put a link down below. So MLRS, go and check out that video, but it means that you can have an MLRS radio sharing the data to and from the flight controller to some kind of ground station. INAV 8 with the changes to MSP, that's going to work an awful lot better and provide a platform for other protocols like ExpressLRS in the future. So if you like a ground station and that's the kind of flying that you like to do, you'll be very happy. Now, in terms of the main list, there are an additional 5 things that Marc has very kindly pulled out that are things that are headliners. And the first one is one that Marc has been heavily involved in. Now, geofencing is something that we've had in other flight control software in the past, where you can kind of draw a rectangle on a screen, and if your model tries to fly out of it, it will do something, usually return to home. But there's some much more sophisticated stuff that's been added to INAV called Geozones, and Marc actually has been heavily involved with this. Why do we need Geozones, and how do we use them?
Yeah, so as you already mentioned, the geofence feature that other systems currently use, like Autopilot or PX4, for example, they are relatively simple. You fly towards one of these designed borders of that fence you design, or this zone. It can be a circle or polygon, for example. It will just trigger a return to home, or maybe a land, for example, to avoid breaching out of the zone or breaching into a non-fly area, for example. But actually, I worked with a Canadian company. They use INAV in commercial ways for wildlife control. It's very interesting stuff. Falcon Environmental is their name, if you want to look the information up. And they needed a way to prevent the pilots accidentally flying anywhere, but keep flying constantly, and also have extra security to not fly through forbidden zones during return to home, for example. So that was basically the reason how that feature came up in the first place. We worked together with an INAV developer, Andreas, to develop a completely new feature for that. We call that Geozones because it is more sophisticated than just geofence, and we wanted to have a different name, of course. And what it basically can do is you define zones similar to geofencing, but INAV has much more sophisticated ways to handle zone breaches, for example. Every time you are in a self-leveling mode, that can be angle, horizon, cruise mode, position hold. Okay, position hold just is for copters because there you can change the position. Every mode that is self-leveling, as soon as you approach one of the borders, one of three actions will be taken. Either nothing, so you can breach it and you just get OSD information. How far in front of you is the breach point for that border? How far is the border itself from your plane, and not only horizontally but also vertically, because we have upper and lower ceilings. The second option would be for fixed wings, especially interesting, the bounce option. So the fixed wing will act like a pool ball, basically bouncing off the border, or like a reflection, and it automatically takes over the control of the plane, turns around and flies away at the same angle as it approached earlier, and then give back the control to the pilot. The second option is automatic return to home, or that's a very special feature because INAV not only just flies straight home, INAV actually navigates around no-fly zones by itself. So it has a path planning algorithm integrated. So if you have a U-shaped, for example, zone you're allowed to fly in, or you have a no-fly zone blocking your path, INAV will automatically detect that and plan a waypoint path, an automatic around it to fly home without breaching the fence. And that's basically the big difference to the current geofence features, that this automation is in INAV and you have more safety, basically.
For me, in one of the places that I fly, there is a country, it's an access road up to a couple of farms that kind of cuts through the middle of the flying area. We try and not fly over the road because although it is a very rural place and it's a private road, we try and stay away from that, because if something happens to the model, we don't want it coming down in that road to either one, hit a car, or have the car drive over it, because occasionally there are postmen and other things using this lane. It would be great to be able to kind of block out that, as if you're returning to home, to actually, rather than fly down the entire length of that road, to tell INAV that actually no, that's an excluded area. By all means fly each side, but don't fly down the road. There's a number of instances I can see where this is actually going to be much more useful than you might think just by the name Geozones. It's also that thing where you can just avoid situations, even things like high tension wires. If there are high tension wires just off the edge of where you normally fly, you don't want your plane accidentally going towards those.
There's even, for that example with the road or with the high tension wires, INAV can also vertically avoid zones. So if you have a zone, a no-flight zone, for example, with a height of 50, 60, 70, 80 meters, like these power lines you mentioned earlier, the big ones, and you are behind that virtual wall, basically, and if the plane returns to home, it doesn't fly along all the track, but it climbs automatically and flies over that zone if there is room for that.
This is actually incredibly useful. I'm much more excited about this now. Now we've had the chat and I understand what it is. So yes, I will definitely be doing a video or two on that when we get INAV 8 videos in production. The next one is something that's been around for a little while. Most people will think it is something that's only come around because of the use of INAV in commercial systems. But actually this one's been asked for by hobby grade pilots for a long time, and it's been in RDO pilot for a very long time. This is GPS fix estimation, or what most of us would call dead reckoning. And this is the ability of a plane to continue to fly and estimate its position on the Earth. If the GPS has a problem, interference, intermittent messages, those kind of things, the plane doesn't freak out, which historically the loss of a GPS could cause some pretty serious issues. Now we have this dead reckoning stuff. Can you talk a little bit about that and what's gone? But it has been in development for a long time, hasn't it, this one? It's been a long time coming.
Yeah, actually, the dead reckoning navigation was already planned by the developer who implemented this in the end for years already, but it was basically not possible because we didn't have the necessary precision of INAV and the necessary calculations in the base AHRS, the attitude and heading reference system, to even realize that. Yeah, it was too hard for INAV without GPS to just keep the heading for a minute, or not speaking alone for longer. Remember the horizon drift issues we had in the past. But then we got the new AHRS in INAV 6.0 that got a little bit more tweaked in INAV 6.1, and after that we had the necessary information with the wind estimator that gives us very precise wind directions and wind speeds, average wind speeds at least. And all these information came together, and on top of that, it was finally possible to develop this dead reckoning navigation. Base functionality of that feature, you don't even need any extra sensor. So the virtual pitot, for example, that uses the wind speed data to estimate your airspeed, is usually pretty fine for short dead reckoning distances. That's not too long, maybe 2, 3, 4 minutes or so of flight before the error really gets big. Not even a compass would be needed, but also very recommended. Of course, if you add these sensors, compass and pitot tube, you get a much more precise estimation. And for my field tests that I did back in the day with my Bixler, and the Bixler is a very slow and gentle and stable plane, of course, I tested a 2-kilometer return to home without GPS fix. So I disabled the GPS in flight. There's, by the way, if someone wants to test that, still in the programming framework, a function to disable GPS in flight with a switch, for example, if you want to try that out. And I tested a 2-kilometer return to home with some slight winds, and I think the final approach was 200 meters off or 250 meters off from my location, but still good enough to gain back RC control, to not crash into a mountain nearby or something. So yeah, it's a very nice feature to get back your craft if you have GPS issues or GPS interferences from other sources. You cannot use the dead reckoning navigation without GPS entirely. You need the GPS, you need the wind speed estimator to having a current wind speed. And you can see that in the OSD, if it gets a small asterisk or it starts to blink, it means the data are stale. And you need to do a few turns, like at least 90-degree turns in one or two directions to regain that wind estimation, because we just assume that after 5 minutes of flight, I'm not sure what the timeout is right now, 5 or 10 minutes, we just assume the wind might have changed too much to have a reliable navigation based on that. So we force the user with that little information on the OSD to make a few turns just to refresh the wind speed data. So you need GPS in the first place before the feature even works. It's really just for a GPS failure.
Next one is a relatively quick one to talk about, actually. This is something that I've shown on the channel. I've built a plane. I'll put a link down to it below. This is the Walksnail head tracker and gimbal support. Now, this is a system that Walksnail brought out. It's actually not a Walksnail unit. It's one that they've repurposed, available in 1, 2 and 3 axis. I have the 3-axis one on my Reptile Dragon 2 with the goggles L, and it is fantastic fun to be able to fly and to look around. However, the way it's worked, or the way that I got it to work, is that the goggle, the IMU in the goggle, was directly sending information to the gimbal via the antennas on the Walksnail unit. We kind of bypassed INAV altogether. So it's nice to see that that kind of support is now in INAV. What does the extra things does that give us?
Yeah, so the extra things it gives you is that you can now use the Walksnail head tracking and feed that into RC channels in INAV. Very important to note here that INAV supports up to 32 RC channels, and you can you can assign the head tracker input to channels that you don't use on your radio, so you don't waste them. Based on that, you can basically also control other gimbals with your Walksnail head tracker. For example, a simple servo pan and tilt. On the other hand, you can use the GM1, GM2, GM3 gimbals from Walksnail, wire them up to UART if you have one free, and you save some wiring and some signal outputs from the flight controller that you can then use for servos, for ESCs, or for whatever else you want. So you basically have a simpler wiring to control the gimbals at the same time.
I just have visions of people trying to use the head tracking function as the RC controls. I imagine this is going to open the door for all kinds of crazy stuff. We're going to have an interesting few months, but thank you for adding that in. I do love the integration of the Walksnail system with INAV. Obviously, I'm a big fan of both, and the way you guys work together just makes me very happy. Next one, this is quite a big one. This is ADSB receiver support. So ADSB, for those of you that might not be aware, ADSB is something that is transmitted by aircraft, and it gives information about the direction, height and speed, as well as identification information. So if you have an ADSB receiver, and actually if you have something like an Orange Cube from the Cube Pilot system, their carrier boards have an ADSB receiver built in. If you plug that into Mission Planner, sorry to talk about Mission Planner in an INAV video, but if you're sat here, you can actually see all the planes that you can see in the distance. If you look on Mission Planner and zoom out enough, if you've received ADSB information, it'll populate that plane on the map with its position, heading, ID. All that information will be available to you as well. Now, this is really handy if you are flying in areas, and let's be clear here, you shouldn't be flying in denied areas anyway, right? But being aware of the other aircraft around you is an incredibly useful thing. And this is only ADSB receiver support. So at the moment, this isn't support so that we as pilots of radio controlled vehicles can transmit ADSB information for other aircraft users to use, but it does allow us to at least see in INAV, like we have been able to do in things like Ardu Pilot, to see other users around us. Is this something that's been integrated into the on-screen display as well, Marc? Is this something we get warnings about? What's the thinking behind this?
Yes, that's indeed the case. So if you install an ADSB receiver, and I think they use what it's called the ADSB MAVLink protocol, so basically standard ADSB messages over MAVLink, then you will also see like AR marker, similar to the INAV radar functionality.
Oh, okay.
You will even see the marker of the closest airplane. Only one is supported, as far as I know, in your HUD. So if you point in that direction, you will see it on the HUD where it is, basically, and you can then avoid it or dive or whatever. So yes, you get the OSD information. You also get, I think it's a separate element for that, and it does not use the system messages. ADSB information, an information string like the aircraft ID number, for example, the altitude and heading maybe, or speed, also in the OSD of any aircraft you receive, or on the closest aircraft that you receive. And the cool thing is, because this is basically exactly the right time, there is a project going on in open, I think it's not open source, I'm not sure right now. It's the Pico ADSB project, where a developer who also worked on INAV and also works on Autopilot and other things created a very, very tiny ADSB receiver and a firmware to basically put in our UAV aircraft. Because we don't transmit with them, they can be very tiny because you don't need these amplifiers and everything. So that will be very interesting, and they should come out within the next few weeks where you can buy that.
Last one then for this video, and again, thank you, Marc, for sparing the time this morning to have a chat about this. And this is another one of your babies. Because you're a fixed wing pilot like me and you're passionate about INAV in fixed wing, this is one of your babies, iTerm lock. What is iTerm lock? Why do we need it? And what's the benefit?
A lot of people often complained about that already in the past, that fixed strings don't fly like quads on especially with INAV. There's always that problem that if you have a very sharp pitch tune, so you want to have this really locked in feeling with the maximum compensation for gusts and turbulences and also that snappy stick feel, there's always that downside that if you do a fast roll or fast pitch maneuver, the plane bounces back. There was never a way around that. The reason for that is basically just the plane's inertia. So you roll very fast and then you snap your stick in the center, and exactly at that moment the stick goes to center, INAV will stop the rotation. But the inertia pushes further. The P term of the pit controller only stops the rotation, but the I term, because it takes a bit, ramps suddenly up, shoots up, and tries to push the plane back into that position where it was when you release the sticks. And that's basically what this bounce back constantly was. And I was bothered by this. This was really annoying. That's why in every tuning guide we say use the integral as low as possible, just enough to compensate for trim errors or something. But that's not the case anymore. Now you can ramp your I-term up, you can lock the plane in as much as you want, because I worked with Pavel on that, and he programmed, he did all the coding stuff, and we did forth and back and testing. I think I probably drove to the field like 10 times in a week to test different configurations for that. What it basically does is, if you deflect your stick from 0 to, I think, 50%, the pits in general get attenuated. They are lowered with the stick movement. Over 50%, the pits are basically zero. They get completely cut, and you only fly with the feet forward. Because the feet forward is basically a direct pass-through from your stick command set point to the control surfaces. Everything above 50 or might be 60% stick deflection will basically fly in manual mode. Right. And the important part is, if you center the stick, P and D gets ramped up again. They scale in real time, but the I term keeps lowered. The I term, if you center the stick, will stay zero or stay lowered until the rotation is within 10 degrees per second of the set point. So only if the plane actually has stopped its rotation, then the I term is reactivated to lock it in place at that point. And this is basically the main thing that stops the whole bounce back you had with fixed strings. And I did some tests on a small craft with very fast rotation, and it really feels like manual mode, like a perfectly trimmed manual mode with that.
That is music to my ears, because I fly a lot of my planes in manual mode for that exact reason. I always felt that INAV felt like it was getting in the way a little bit in ACRO. And again, the difference between manual mode and ACRO is that manual mode, INAV is literally doing nothing apart from adding expo and doing your mixing. But with ACRO, you still have all of the PID double F loops kind of helping you along. I never used ACRO because for exactly that reason, I felt that manual always gave me a much more direct, crisp response. It is really exciting and I will be testing that ACRO performance with that new feature.
And if you like that crispy response, I think with this feature and using ACRO mode, you will be even more happier, because if you compare that in manual mode, if you center your stick, the control surface is just center, and the inertia and the aerodynamics of the plane will stop it. But with that new feature, the P term will actually stop even more aggressively. So then you get this really sharp stick feel without the bounce back issues.
So it's almost going to be closer in behavior to a quad than it is to a traditional fixed wing. Okay, I'm definitely going to play with that. Marc, thank you so much for the time today. Thank you for putting this list together. I really appreciate it. Thank you to you and the rest of the team for continuing to develop INAV and bring out some really cool new innovative features. I know lots of other projects have this kind of life cycle where, you know, they kind of get really interesting and then all developers get bored and move off onto something else, which is sexier and more fun. I just really appreciate you guys continuing to look at the issues, the logs, add all these features that we asked for as pilots, improve, add new targets and all that stuff, it is incredibly appreciated. And I personally, as a pilot, just want to say thanks, because I get an awful lot of fun out of your technology in INAV. Never mind making all the bloody videos for everybody else. So let's put a line under it here. Again, time codes, as I said at the beginning, for all these questions below. Do refer to the documentation as it changes. And if you have a specific thing that you want to see a video on, hopefully Marc will help me figure some of this stuff out. We'll definitely be the one on Geozones. I think that's really interesting. I'm definitely going to play with the Walksnail and head tracker stuff. And I'm sure you'll see lots of videos from the usual suspects on people testing the new iTerm lock to see what difference it makes. Thanks again, Marc, and thank you everybody for watching, and I'll see you all soon. Bye for now.
Thank you for watching my video. Check out the playlist, and adding Painless 360 to your search terms will help you find my content. If you haven't done so already, please hit the like and subscribe button. It helps a lot. You can support the time I spend here answering questions and helping others by using the links in the video description.